Power functions and polynomial functions. Thanks, Mason. Y'all know a lot about this already. I think that you'll be able to say, yeah, this isn't so bad. Okay, it'll take you a minute to think that you know anything, but you'll be fine. All right, so a power function. A power function is a function that can be represented in the form f of x equals k times x to the p power. K times x to the p power. There's a power function. And it's important to be able to recognize these because later on we'll use something called the power rule a couple of years from now. And the power rule only works on power functions. So it's important to be able to tell what are power functions. K would be the coefficient here. K is the coefficient. It would be the number in front of the x letter. Okay. And p is a real number. Could be positive, could be negative, could be a fraction. Okay. So, yeah. So, is f of x equals 2 to the x power a power function? No, it's not. Well, why not? I see an exponent. There is an x, but this has to do with the location of x. In a power function, x is in the base. X is in the base. It's the bottom number, and we raise it to a number power. This is an exponential function, where x is in the exponent. Okay, so power functions have x in the base, in the bottom. You'll have x to a number. An exponential function, which we haven't covered yet, will have x in the bottom, in the top, where the exponent is. Can you see the difference in the two? Can you? Really? Yeah. X to a number versus a number to x. Two different things. Okay, so let's look at your toolkit functions. This is going to be example 1. And we're going to tell which of the toolkit functions are power functions. So you got f of x equals x, f of x equals x squared, f of x equals x cubed, f of x equals square root x, f of x equals the cubed root of x, f of x equals 1 over x, f of x equals 1 over x squared. I think that's pretty much all of your all of your toolkit functions. Yeah, we could do the absolute value one. We could talk about it.
What are we supposed to be finding out?
Well, which ones of these are your power functions?
Well, are they all?
So power functions mean I have x to a power of something.
Oh, wait.
He said, aren't they all?
X squared, x. 1 over x squared. I'm not sure.
Okay, so this one is for sure. This one is for sure.
1 over x squared.
What's the power on this f of x equals x? Let's start at the top. 1, x to the first power. So couldn't that be considered as a power function?
Yeah. But wouldn't it be x to itself?
No, it would be x to the first power. Yeah. How about, I'm hearing these two. These two are power functions. Well, if I write it as x to the something power, it would be. What's 1 over x as a power? X to the what would give me 1 over x? How do I get in the basement? -1. -1. This goes back to your exponent properties. X to the -1 power is the same thing as 1 over x. So if we'll rewrite it, sure, it's a power function. Same thing for f of x equals 1 over x squared. How is it written as a power? X to the negative 2. Good. We have 2 more. Is there any way we could write the square root of x as a power? X to the what power equals the square root of x? 1/2. This is your rational exponent properties. Good. 1/2. If I raise x to the 1/2 power, that's the same thing as square rooting it. It could be written as a power. How about the cubed root of x? X to the 1/3. Perfect. Yeah, that's a power. So actually, all of these except absolute value of x could be written as power rules, power functions. Cool. Any questions on that? No? Okay. Of the following, which are power functions? You've got f of x equals 2x times 4x cubed, and g of x equals negative x to the 5th plus 5x cubed. Aren't they both? They both have power functions in them. The first one could be multiplied together. The 2 and the 4 would give you 8. And x times x cubed gives me x to the 4th. When I multiply like bases, I add my powers. This one is for sure a power function. I would say this one that includes multiple power functions would be better called a polynomial function. So you're not wrong. There are power functions in there. But when we have more than one at a time, we usually call it a polynomial function. And we'll get more into that today. Any questions here at all?
How come the top one's not called polynomial?
Because it's only one. It's a monomial. Once I multiplied it together and simplified, I don't have them being added and subtracted. I just have one. 8x to the 4th. Good question. Any other questions here? Okay, so I'm going to try to find a picture that I took earlier today. Yep, this one. So this one says identifying end behavior of power functions. Identifying the end behavior. When we talk about the end behavior of a function, we're talking about the function's tails, the arrows. As it goes to positive and negative infinity in x, what does f of x do? What does y do? Okay, so look at this picture. What do all of these power functions have in common? You got x squared, x to the 4th, and x to the 6th. They're even. All of these functions have even powers. On an even power, the tails both go the same direction. Think of the quadratic. This is f of x equals x squared. That's this teal one. Can you tell that both tails go up here? The reason they do that is because it's an even power. So either it's, yes, because it's symmetrical. He said it's symmetrical on the y-axis. Yes. Both tails are going to go up, or both tails are going to go when? When would they go down, both of them? If it was negative. Perfect. If the leading coefficient was negative, they would both drop to the bottom. Okay? Let's look at another picture. This one. You got x cubed, x to the 5th, and x to the 7th. And they're odd. Can you tell? And so on odd power functions, the tails go in opposite directions. As x gets bigger, y gets bigger. As x gets smaller, y gets smaller. What would make them flip-flop and go the other way? Again, if it was negative, if they were reflected. Okay, so I have a big chart, and I'm going to pause and give you some time to get this chart in your notes. It's going to be super important that you get all of this information down. Yeah, I know. It's a big chart. So I'm going to put it, and then we're going to talk about it, but I'm going to pause while you get it written down. Okay, so for an even power, if k is positive, the tails go up. And we're not talking about anything that happens down in this area. We're talking strictly about end behavior, meaning what happens on the tails. So if k is positive, the tails go up. And then we're going to talk about this piece of information down here at the bottom, and I want you to get it written down really well. It says, as x goes to negative infinity. So what is that saying? As x goes to negative infinity, that means as we go left. This is x goes to negative infinity. That means I'm going to the left. What happens to f of x, or y? Goes to positive infinity. That means y goes up. So you're reading at this point the left tail. Then we have the second statement down here, as x goes to positive infinity. That means I'm getting bigger in x. I'm going to the right. What does f of x do? It stays positive. It also goes to positive infinity. So those tails are going to match on both sides. Can you understand what these symbols down here are saying? As x goes to positive infinity, f of x goes to positive infinity. Are you ready to come over to the next one? This is if it's positive and odd. Positive and odd. X goes to negative infinity. What happens to f of x? As I go to the left, what does the function do? It goes down. As x goes to positive infinity, what does f of x do? Goes up. Can you tell that your f of x pieces of information are opposite here? One goes to negative and one goes to positive. Would you like me to quit drawing on the picture you're trying to write down? The last two go when x is when k is negative. You might have a negative coefficient, and all that does is reflect it. So if they're even, both tails still go the same direction, but they go down. So both of your f of x statements will go to negative infinity, here and here. And if it's odd, your left one will go up and your right one will go down. This really mimics how it looks on a linear function. The odd ones really all behave like they do on a linear graph. So here is example 2. We've taken a very lengthy amount of time to get to example 2. Say it again.
That wasn't even example 2.
No, that was the chart. All right, example 2. It says describe the end behavior. Describe the end behavior. I'm kind of cutting off words here. Describe the end behavior of f of x equals x to the 8th. So without graphing it, without looking at the picture, what do the tails do? They go up, right? So we have to say this. As x approaches both positive or negative infinity, because they do the same thing, whether I go right or left, f of x approaches what? Positive infinity. They go up. And that's the answer. As x goes to positive or negative infinity, doesn't matter if I go left or right, both tails go up. Can you understand that? Okay. Here's example 3. Example 3. It wants the end behavior of f of x equals negative x to the 9th. Okay, so it's negative. So it's going to be like a negative line. I always think that the odd ones behave like a line. So if it's negative, it's going to look like a negative line, and the tails are going to do what the negative line tails do, right? So as x goes to, let's go to the left first. As x goes to negative infinity, what does f of x do? Positive infinity. As x gets smaller, f of x gets larger. Can you see it? F of x goes up. And as x goes to positive infinity, what does f of x do? It goes down, negative infinity. So really, this one's going to look like this on the graph. Any questions? No? Okay, you got one more in you? How about negative 5x to the fourth? F of x equals negative 5x to the fourth. Both going down? Why? So as x goes to positive or negative infinity, f of x goes to negative infinity. This is the try it. That would be your try it. As f of x, or x goes to positive or negative infinity, f of x goes to negative infinity. Both tails are going to go down on that one. It's going to look like an upside downwards. Everybody good? No. Okay. All right. So here's your example 5. They introduce a polynomial function. Polynomial functions. Gosh, I cannot spell today. Polynomial functions. And what I think of a polynomial function is that it's a sum of several power functions. So it's just more than one power function, all kind of lined up and added together. Okay? So if I had something like f of x is equal to 3 plus 2x squared minus 4x cubed. Standard form says we got to put it in order from highest degree to lowest. Do y'all remember rewriting these at the beginning of the school year? So if we do that, we have negative 4x cubed plus 2x squared plus 3. Everybody good with that? And so out of this function, I'm going to ask you some questions. What's the degree? The degree here would be 3. What's the leading coefficient? Good. Leading coefficient. Negative 4. What's the leading term? Good. Negative 4x cubed. These questions can only be answered if this thing is in order, from highest degree down to lowest. But once you have this, you can ask the question, what do its tails do? Can we describe the end behavior of this function only given this information right here? Yes. So as x goes to, which side do you want to go to first? The right or the left? Left. As x goes to negative infinity. So this is negative odd. So it should go down from left to right, right? So as x goes to negative infinity, what does y do? F of x goes to positive infinity. So we can describe the end behavior here without ever having looked at anything. As x goes to positive infinity, what does f of x do? Negative infinity. Good. Good, good, good. I've got some more pictures of that. Do you want more pictures of that, or are we okay here?
I'll have everything go.
Well, I've got some more of these examples. Do you want more of these examples, or are we okay? We'd like another one with the polynomial? Here, let's try one more. Given g of t, this is still example 5. Given g of t equals 5t to the 5th minus 2t cubed plus 7t. Not 7 to the t, 7t. What's the degree? What's the leading coefficient? Leading coefficient is 5. It's positive, isn't it? So we have here a positive odd. So that means it's going to go up from left to right. So if we write our limit statements here, we're going to have as x goes to negative infinity, what does f of x do? F of x goes to negative infinity. And as x goes to positive infinity, f of x goes to positive infinity. Is that feeling okay for y'all? Better now? Oh, I'm sorry, Mason. You got it. Good? Okay. All right, let's look at another picture. It's going to be example 6. It says identify in behavior and degree. So look at this picture. What do you think the degree could be? Do you think it's odd or even? Odd. So it could be 3. Degree could be 3. Could be 5. Could be 7, right? It's definitely not even. How do you not know it's not even? Because the tails go in opposite directions. Okay. How about this picture? Odd positive, right? How about this one? Even negative. Can you tell? Because both tails go down. Okay, so we're not struggling with this. I have one more question for you. This is example 7. And believe it or not, this is actually the last thing we have today. It says, given the function, this is example 7, by the way. Given the function f of x equals negative 3x squared times x minus 1 times x plus 4. Write in standard form determine the leading term degree and end behavior. So the first thing we're going to do to write it into standard form is FOIL out these two binomials. We're going to FOIL those first. Okay, so I'm going to have my 3x squared in front. It's negative 3x squared in front. And then we're going to FOIL x minus 1 and x plus 4. So first we have x squared, and then plus 4x minus 1x puts me at plus 3x. Very good. And then negative 1 times 4 minus 4. Then we want to distribute this negative 3x squared through all three terms. So we have negative 3x to the 4th minus 9x. What happens when I have x squared times x? X cubed. Good. Multiply like bases. I'm adding my powers. minus 3x squared times minus 4. Negative 3x squared times negative 4.
Negative 12x squared.
Plus 12x squared. It's positive. A negative times a negative. So do we have it in standard form here? Are they listed in order from highest degree to lowest? So then what's my leading term?
Negative 3x.
And what's the degree? 4. So this is a negative even. So now, how do we describe our end behavior? As x goes to, he said both do the same thing. So as x goes to positive or negative infinity, comma, f of x does what? Negative infinity. Both tails are going to go down here. Very nice. That's it. That's the whole lesson. All of the homework is in Canvas. You guys were wonderful participants today. Good job.